Okay, good morning, everyone. It's 9 o'clock, and I would like to welcome you all to our Aalto Sustainability Talks seminar this morning. We are going to discuss sustainable construction today, and on behalf of our Aalto Sustainability team, I would like to welcome you all. I will hand over the chair to Professor Pekka Heikkinen, who is Professor of Architecture and specialized in wood construction and eco-efficient building. And he will guide us through this session today and give also some practicalities here in the beginning. Are you, Pekka, ready and online?
Yes. I guess I am here.
Please, the floor is yours.
Yeah. Good morning, Paula, and good morning, everybody. As Paula said, we will talk about sustainable building construction today in 3 viewpoints. We have 3 very compact presentations first by Matti Kuittinen, who will discuss the issue in quite global perspective and think about the ways to improve our performance in building sector. Then Juudit Ottelin will take a look at the little bit of user or consumer viewpoint, and Professor Matti Kuittinen will close the session with talking about how we could improve the life cycle or performance of the building materials in the future. The presentations are very short, and we have reserved a little bit of time for you for discussion. So please send the question to chat or raise your hand. We have time for a few questions after each presentation and at the end of the session. And please, when you speak, open your mic and camera as well. On the other times, please keep it muted since we are quite many. So maybe I will give straight the screen to Matti and try to spend the time effectively. Matti has a double role as a professor in Aalto University and as well as specialist in ministerial environment, where he plans the new ways of building the future for us in European, at least European or planetary viewpoint. Good morning, Matti.
Good morning, Pekka, and good morning, everybody. Thank you for the invitation to this event, and let's start my presentation. And I hope that you can see the screen now. So my title this morning is Architecture for the Anthropocene. It seems that we are approaching something that we should not be approaching, and we should change the ways that we behave on this planet. And that's the viewpoint to my talk to this morning. I will present to you 3 facts and then elaborate towards a bit more philosophical directions based on these facts. But first, what is the Anthropocene? It's a geological era during which the human actions have permanently been recorded into the layers of our planet's crust. We see traces of plastics, heavy metals, other sorts of pollution, greenhouse gas levels increasing, and our destructive action is now permanently recorded there. This was brought up by the Secretary General of United Nations, Antonio Guterres, last December in his first speech about the state of the planet. And he had rather grim messages, I'm afraid. He said that humanity is waging a war on nature. This is suicidal. He also said that biodiversity is collapsing and ecosystems are disappearing before our eyes. And he went on saying that apocalyptic fires and floods, cyclones and hurricanes are increasingly the new normal. And he ended up by saying that, let's be clear, human activities are at the root of our descent towards chaos. That was quite a heavy message from him. So he concluded that making peace with nature is the defining task of the 21st century. So my question this morning is that how can we make peace with nature? and more specifically, what's in it for architecture. So now to the 3 facts and 3 viewpoints. First of all, I argue that we should reconsider the needs for construction. And this is relatively simple by just looking at the global statistics. If we look at the consumption of 4 mostly produced raw materials, steel, plastics, aluminum, and cement, we can see that their current production ways would lead to close to 920 gigatons of CO2 emissions by 2050. Now, this is almost twice the amount of emissions that we could afford to cause if we wanted to keep the planet from warming beyond 1.5 degrees. So if we change the way we make these materials by introducing energy efficient factories and zero carbon energy, we could lower these emissions, but that's still not enough. And it appears that only with radical interventions of circular economy, we could push these emissions to around 300 gigatons, which would be the absolute maximum. Now, why is this relevant for us this morning? The reason is that these materials are mostly used in construction, not entirely, but construction sector is the main consumer of all these 4 materials. So therefore, this is important for us. So that's why we could ask help from ancient Chinese general Sun Tzu. He was not a general expert in the topics that we are talking today. He was not a master of sustainability, he was master of warfare. And he wrote in his famous book, The Art of Warfare, that it's the highest level in warfare is not to defeat your enemy in the battle, but the highest level is to defeat your enemy without the battle. And if we translate this to the language of architecture, we could say that could we solve the problems, or could we satisfy the user's needs without building anything? And therefore, I'm suggesting that we should have a hierarchy for resource efficient construction, in which the first priority would be to do nothing but just utilize existing spaces. Thereafter, renovate them. And then as a third option, refurbish an old building. And as a last option, if none of these work, then consider building a new one. This is a straightforward manner and of course does not fit to all purposes, but this would be something that we could consider if we were to drastically reduce our material intensity, especially in the construction sector. Then my next point is that we should improve the resilience of the built environment. By looking at the facts, it's clear that the number of natural disaster events has gone drastically up. And we can see clear linkage to anthropocentric climate change here. We can see that there is more storms, the intensity of storms is increasing, there is increased flooding in certain regions, and this is of course very detrimental to construction. So if we were to make our buildings more resilient towards these changes that seem to be going on, should we consider something that's more simple, that's something that's more robust when we talk about the materials for construction? Should we consider solid materials? Should we consider massive materials or even vernacular materials that would be so much easier to extract from the nature without heavy processes? If we fail in addressing the urgency of climate change, it may that we go beyond the tipping point of the melting of global glaciers. And that would cause significant sea level rises in the future. At that point, or even before, the resilience would not be just against the forces of nature, but also against social and economic unrest, which might be very significant factor for the maintenance and funding of the buildings that we have today or wish to repair tomorrow. My third and final point is thus that I think that we should question our anthropocentric construction culture. At the moment, 90% of global biodiversity loss is caused by extraction of natural resources. And furthermore, 50% of all raw materials are used for construction. And the trends are unfortunately pointing at the wrong direction. If we look at the graph here, we can see that there is increased need for using more materials for construction. There are logical needs, of course, for that. The global population is growing, and most of these settlements and homes and schools and shopping malls that the future generations would need are yet to be built. And furthermore, we have aging infrastructure which needs to be repaired, not least because of the changing weather stress to structures. And further, we also have the problem of rising sea levels. So all of these will result into increased need of construction in the future. But while we are consuming half of global raw materials every year to construction, we are doing that on the cost of our neighbors in this planet. While we extract materials, we take that from the habitats of animals and plants and other species of life with whom we are sharing the only habitable planet that we know of. Should we reconsider this? Could we, instead of just being an extractive and destructive force currently on this planet, could we consider ourselves as one of the many forms of life with whom we are sharing this dear planet Earth? If we could consider ourselves in this position, then we could perhaps ask a difficult but much needed question. Which home is more important? Is it more important that I can build myself a summer cottage on a nice place? Or is it even more important that some endangered species or species that might be endangered could maintain their habitat on that spot? What is my right to build? And I'd like to conclude by saying that the architecture for the Anthropocene, from my perspective, is that we should increase the quality of a building and decrease its harmful impacts. How would you decide if you would like to make peace with nature?
Thank you, Matti. So, radical intervention, in your opinion, might mean, do we not to build new, and if build simply more robust? And then you used several times the word could and if. What is your opinion? It was quite a heavy start for Friday morning, but what is your opinion? Can we?
I'm very certain that we can. There is all of the problems that we have caused are not forces of nature. Our consumption is not a force of nature, nor is it a law of physics. We can change it. But it's interesting to see how fast we can do that. And I agree, it's a heavy start for Friday morning, but I happen to know what interesting stuff the next presenters are about to bring. So I chose deliberately this sort of a bit more polemic and philosophical approach to the topic. So there is hope, definitely.
Thank you, Matti. We will move on. Juudit, Ottelin, discussing about the choices that what are available. Juudit comes from the real estate business, and her research focuses as well on environmental impact, economical activity, and human behavior, which sounds like a complex combination. But let's hear you, Juudit. I guess you are here.
Yes, thank you, Pekka. My apologies, my video isn't working. I tried to restart my computer after my own presentation, so I will hopefully get it on later. But I will start sharing my presentation. Okay.
Now it's fine.
Yes. So as Pekka mentioned, I'm from the Aalto University's Real Estate Business Research Group, and I'm there as a postdoctoral researcher. My research has focused on the carbon footprints of consumers in the context of built environment. And today I will talk about wooden housing as a sustainable consumption choice. So I will start from these global carbon budgets and then scale down to the consumer level. And then I will try to answer the question, is wooden housing carbon negative? So does it go to the positive or negative side of the consumer's carbon budget. And then I will give a short introduction to these unintended consequences of sustainable consumption choices. So those are called rebound effects. And also wooden housing has some interesting rebound effects, like any other sustainable consumption choices. And then I will shortly show some of our preliminary results from our paper that looks at these impacts of wooden housing on consumers' carbon footprint and handprint. And by handprint, I mean these negative emissions from carbon storage. And then I have the conclusions. Okay, so let's start with the global carbon budget. So as you can see, we are causing a huge amount of greenhouse gas emissions globally. And then if we look at the sinks, the ocean and land sink absorb about half of the greenhouse gas emissions that we are causing, and then half of the emissions are remaining in the atmosphere. And in Finland, the balance is a little bit worse than I expected before or believed before. So we have around 56 tons of territorial emissions, and then this consumption-based carbon footprint, that's around 60 megatons. And our net sink from land, mainly forests, is around minus 20 megatons annually. So we are actually quite far from the carbon neutral targets at the moment. And of course, when we talk about wood construction, we should ensure that we are not decreasing this forest sinks, but have this sustainable forestry where we plant equally much forest as we cut down from the sinks perspective. Okay, and then if we go to the consumer level, the sustainable level of carbon footprint would be around 2 tons of CO2. And here you can see some Finnish carbon footprints. The average Finnish carbon footprint is around 10 tons of CO2. And in this recent paper by Kalaniemi et al., we looked at this universal basic income level carbon footprint. So if we would all downscale our consumption to the basic income level, how would the footprints then look like? And we found that they vary from 4 to 6 tons of CO2. So although they are much lower than the average carbon footprint, they are still quite far from the sustainable level of footprints. And of course, this is a very worrisome message, considering the not only these climate goals, but also these sustainable development goals related to the reduction of poverty. So if you anyway would like to have a carbon footprint that is at the sustainable level, you can see that it's difficult by only reducing your consumption. So you need other solutions as well. And there are, of course, technological solutions like renewable energy. But you can also try to increase this kind of negative emissions, which we call here the carbon handprint of a consumer. So by these negative emissions, I mean carbon sequestration and storage, and the things that are related to that, activities and consumption that is related to carbon sequestration. So for example, planting of trees or restoring natural areas, or carbon smart gardening, which is the main topic of our ongoing co-carbon project. And also in this presentation, I talk about this wooden housing. But then the question is that, is wooden housing actually carbon negative? Wooden housing has lower life cycle emissions than other type of construction, for example, concrete and steel, but this only means that it has lower carbon footprint. So here in the balance, it means that you have a lower carbon footprint from this shelter category. But then the handprint would be the carbon storage of these wooden buildings, because that is related directly to the carbon sequestration of the forest if we have sustainable forestry. And in traditional LCA, these negative emissions are, or this carbon storage is not taken into account because it's considered temporary, which means that the storage will be destroyed in the end of life of the building. But however, these recent studies have highlighted that there may be significant climate benefits from storing the carbon for these like 50 or even 100 years in the buildings. And it's also possible that after 100 years, we would have some pyrolysis facilities or something that we could deal with the end of life process so that the storage is not destroyed even at that point. Okay, so maybe we can put wooden housing in the handprint side, but that's still uncertain according to the current literature. The carbon storage varies from around 100 kilos to 300 kilos per square meter. This is a review by our PhD student Alia Mire. And then yes, so if somebody says that the carbon storage can even be bigger than the carbon footprint of the construction, they are using the process LCA, which usually takes into account only these main processes related to the production, but then there is this truncation error of leaving out the upstream emissions. And when we are talking about carbon footprints, we usually use this input-output analysis, which is a more comprehensive method that leaves no upstreams away, but takes them into account until the infinity. It's a mathematical model. So when you use input-output modeling, the carbon footprint of construction is always larger than the carbon storage. So in that sense, wooden housing is not carbon negative. Okay, so let's go to the sustainable consumption choices. Basically, we have two types of sustainable choices that we can make. First type is that we are actually saving money when we make these choices. For example, if you give up car ownership and start cycling and using public transport, you are saving around 1,000 euros per year, and then you usually consume that on something else, and that increases your carbon footprint of your rest of consumption. And this is called a rebound effect of consumption. But then there is also this kind of nicer side of rebound effects, which is that if you actually spend money in making these sustainable choices, for example, make a sustainable investment, for example, in these solar panels or electric vehicles or wooden house, for example, then you actually have to take that money from your other consumption. I mean, you have to save in order to purchase solar panels. So it reduces your other consumption, and thus it reduces your rest of consumption. Well, I will show one example, and this also relates to what Matti was talking about, the kind of retrofitting or not constructing new. I have sort of a viewpoint to this that this is often not considered, which is the rebound effect of the investment. Yeah, so in this picture, I compare these old house residents to new house residents. And in this paper of ours, we were interested in the energy efficiency of new buildings, and we indeed found that the carbon footprint of housing energy is around 400 kilos lower in these new houses compared to the old house residents. But then if we look at the total carbon footprints, we can see that there is actually around 1 ton reduction or difference. So the carbon footprint of old house residents is around 11 tons, and in new houses it's less than 10 tons. So we have, in addition to this 400 kilos, 600 kilos reduction from other consumption categories. And if you look at where it comes from, it's from the tangibles, so that's like electronics and clothes and all kind of stuff. And then the food consumption, other travel, which includes holiday travel and public transport, and then from driving and private vehicles. And there is no clear explanation for this, like why do you reduce your other consumption, except that if you look at the expenditure of these two consumer groups, we can see that these new house residents have higher housing loan payments, and thus they have less money for the rest of consumption. So this is a negative rebound effect of the green investment, in this case, the new house. So this relates to the question that is it actually better to retrofit these old buildings than construct new? But then, of course, when I show this picture, someone always points out that there is this carbon spike of construction, which is true. It's around 45 tons per person when you construct a new building. So it's much higher than even the annual carbon footprint. But on the other hand, that is like one-time impact. So it would be interesting to look at this together, like if we have this carbon spike, initial carbon spike, but then we have this negative rebound effect, then what is the total outcome? And this is what we looked at in our latest paper now, where we look at this issue particularly from the perspective of wooden housing. So the article is currently under review, so I won't show you the exact results, but I will tell you a little bit about the preliminary findings. So indeed, we found that the wooden house residents have lower carbon footprints. And this is because of the lower carbon footprint from the construction, and then the carbon storage, and these have like a similar size of effect, around minus 200 CO2 kilos to the total carbon footprint. But then there are also these additional reductions in the rest of consumption, which may be because of rebound effects, but there isn't actually such a big difference in the expenditure of these wooden and non-wooden house residents. So we also considered that it might be because of other omitted variables, for example, lifestyles, since old wooden houses fit very well with this bohemian lifestyle, which may be like environmentally oriented, whereas in the non-wooden group, non-wooden house residents, we have these high-end detached houses, which are usually constructed from stone and glass and other materials aside from wood. And also these households probably are not environmentally oriented. So it may be that the regression model actually captures some of these lifestyle differences as well, which means that the impact is not the impact of the wooden housing, but rather the impact of the underlying attitudes that affect the carbon footprints. Well, in any case, when we look at these investments scenarios, so when we try to kind of combine this impact of the initial carbon spike and then the negative rebound effect on consumption, in these scenarios, it seemed that in the urban areas in particular, investing in a new wooden house is the best option compared to non-wooden new houses, but also compared to choosing to live in an old house. So this is kind of counter argument towards the retrofitting instead of building new, but then you have to remember that this is in the current economic model. So of course, Matti was talking about shifting to a circular economy. And if we do that and we have legislation, for example, to increase the price of carbon, then the situation changes dramatically. But in this moment, in this current situation, if we start retrofitting without changing any legislation, we end up with this significant rebound effects, which must be taken into account. Okay, so as a conclusion, I would say that wooden housing indeed is a sustainable consumption choice because of three reasons. So it has lower life cycle emissions from the construction. Then there is this significant temporary carbon storage, and then the negative rebound effect of the investment, which reduces other consumption and the related carbon footprint. And in addition, I wanted to highlight that the carbon negative balance is quite difficult to ensure, like whether we are talking about consumers or nations or cities or anyone, because the existing sinks are already taken into account in our climate targets. So how do we make sure that we are actually increasing the sinks and not just like shifting the ownership of the existing sinks? And then there is also this concern that the focus on sinks and negative emissions at the moment may be a distraction from the emission reduction. So what I'm worried is that when we talk about this carbon neutrality or carbon negativity, the citizens get the kind of view that we are already in a good place concerning our climate targets, when in reality we are still here. The emissions are still increasing, and we have not managed to make them turn down. Okay, thank you.
Thank you very much, Juudit. Most interesting presentation. Unfortunately, we did only have 15 minutes time because we could discuss about this about a few days. Maybe there was already after Matti's presentation a question about the urban development. People are moving to the big cities, and Alessandro, you asked a question. It seems that Matti already replied on that question on chat. Matti, could you shortly open the question issue?
Yeah, well, mitigating the urban sprawl is of course on a general level, that's a priority, but I think there are limits to densification as well. So while trying to limit the urban sprawl and trying to make our cities more dense, we are of course promoting material efficiency and hopefully also material dependency and material intensity of buildings that we create and the infrastructure. But at the same time, we are decreasing the area and capacity of urban ecosystem services, which are not only important for climate or carbon sequestration in urban areas, which is a significant impact as well. But they have so many co-benefits that we shouldn't densify our cities beyond certain levels. And what's that certain level? That appears to be very context specific.
Yeah, and then you pointed out in the chat that there's, for example, in Helsinki, there's a lot of potential in existing buildings. So there is not urgent need to build more at the moment. Then there was a question straight to Juudit. There's quite a vivid discussion in the chat. Thanks for that. Hanniina Manner, could you ask the question publicly? And I guess this goes to Juudit or anybody.
Yeah, to Juudit or anybody, and concerning, I had the example there about the bikes, electrical bikes, but like I have a little bit of a problem with this rebound, or I don't understand it well enough. Like if you save money while you're doing an environmental need, or like refitting your house instead of building a new one, or or buying the electrical bike and saving money. Is it always that, like if you choose not to consume more, is there like how does it still always increase the amount of spending? If I don't do it myself, is it then like because I save the money, it's via the banking system, they lend the money to someone else who consumes it? Could you maybe open up this idea behind the rebound a little bit more, because it's a very interesting concept. Thank you.
Thank you, Hannina, for making quite complex issue even more complex. But Juudit, hopefully you have a clear answer for that.
Yeah. So rebound effects are, of course, very different depending on the individual. So naturally, we all have our consumption habits that, for example, when I save money, I usually put that on my living expenses, like I'm paying the housing loan, and then someone else may be saving for a holiday trip, and someone else may be saving for the grandchildren or something. So of course, depending on the individual, the rebound effect varies a lot, depending on what is your kind of marginal consumption, where you put your extra money. But what I'm studying is the average carbon footprints. So they reveal the average rebound effects in Finland, in this case, when I'm studying the Finnish carbon footprints.
And then there's a quick one from Sari Kuvaja, please.
Good morning and thank you. Yeah, I just was wondering if you have taken into account the potential impacts of the logging of the raw material for the wooden construction, if these are taken into account in these calculations. You might have told about that, but I just wanted to make sure. And of course, then we have the question of biodiversity, but that is another story then. Thank you.
Yes, thank you, Sari. These are really important issues. We did not focus on these things in our paper. So as I mentioned, we assumed that there is sustainable forestry sector, which in our case means that the carbon sink is maintained as it is. So it's not increasing or decreasing. We assume that it's stable in our paper.
But that is rather an assumption.
Yeah, well, we are not studying like the increase of wooden construction in this specific paper. We are just comparing the carbon footprints between the wooden house residents and the non-wooden house residents.
Okay, thank you.
By the way, one comment. I don't know how aware people are about the development of wood construction, but we are talking about quite high buildings and quite urban scale, like the highest wooden building at the moment is 18 floors, 18 stories, and referring to Juudit's kind of notion about bohemian lifestyle, it seems that wooden living in a wooden house will be maybe quite trendy as well, as it has been for some 17,000 years. But very interesting issues that you pointed out was the carbon sink, that what should we do with our forests while we are at the same time mining minerals from the ground and building as we have built past 60 years or so. And then you pointed out that your study was based on the current way we run the business. Not, and you said if we turn to circular economy, would it change a lot if you said that when we change? But any estimation how your kind of diagrams would look like? We will maybe hear more about that in Mark's presentation next. But Juudit, do you have a very quick comment for that? Or maybe a little bit confusing question again? Sorry about that.
Yeah, I think that, you know, people often ask from me, like, what can we do to reduce these rebound effects? But I don't think that that's the right goal. I think that we should decrease the greenhouse gas intensity of our economic system in general. So when it would be lower like if we increase the carbon price so that every consumption category has the same low greenhouse gas intensity, then the rebound effect is always 100%. So it doesn't matter where you put the money, the carbon footprint is the same in any case. So that's kind of my ideal world, which I'm kind of trying to target my policy implications.
Okay, thank you very much. Now we, as I said, really interesting presentation, but now we have to move on to Mark Hughes. Mark is originally a mechanical engineer who did his doctoral thesis in wood, I guess, and then you turned to a professor in wood product technology. And I guess you have an opinion about circular economy as well, so let's hear that. Ole hyvä. Please, Mark, screen is yours.
Kiitos, Pekka. Can you see the screen okay?
Yes.
And hear me, everybody? Yeah,
we
great.
can hear you, yes.
Thanks, Pekka. Good morning, everybody. And thanks, Pekka. I never realized I could actually be maybe trendy. I live in an old wooden house, so I'm both bohemian and trendy, it seems. So I'm very, very pleased to have that classification. So yeah, I'd like to just spend a bit of time talking about perhaps the need for materials efficiency in the future, and to pick up, I think, a little bit on Matti's and Juudit's talks a little bit. So I won't go into any more background detail, but just to say that, of course, why are we interested in wood construction when it comes to kind of climate change mitigation and other reasons? And I think, of course, we know that when we're building with wood, then we are substituting other more energy intensive materials, concrete and steel in particular. We've heard also about the ability of wood and wood products to store carbon long term, and of course wood is a good, not only a good structural material, but it's also pretty thermally efficient, and also because it's a pleasant material and it interacts with the environment, it's also able to some extent passively control the interior of buildings, which can lead to some health benefits and at least well-being benefits. And this is also being researched. But today I'm going to concentrate on the substitution and the carbon storage effects and how we might in the future be able to promote these further. There's been quite a lot written about the potential of wood construction to kind of change the paradigm on construction itself and change the built environment into a carbon sink rather than a big source of emissions. I mean, this is just one of several papers that have come out in the recent past looking at this role. I think it raises some very interesting questions. Of course, there's this huge potential here, and for sure we could do an awful lot more to promote construction, wood construction. And so I think it's probably true to say that we do still need mechanisms, incentives to increase the amount of wood construction, particularly in Finland, for example, in mid-rise buildings where it still hasn't penetrated to as great a level as we might expect it to. Of course, in the residential housing markets, single family houses and row houses, I mean, it's been dominant there for many, many decades, even centuries. So there's maybe some room to increase the building there, but probably not as much as it is in urban areas and in mid-rise buildings, high-rise buildings, and also in other commercial buildings. But I mean, I think it was Sari in the audience who raised this issue about what happens in the forest. I think this is a critical thing, that we need to be absolutely sure that what we're doing is actually leading to an overall benefit, and we're not creating bigger problems than we are actually trying to solve. And there's been papers that have been published quite recently questioning our route into wood construction and the expansion of the bioeconomy because of the impact it will then have on the ability of forests to supply the material and also to retain the other ecosystem services such as the carbon sequestration and the maintenance of biodiversity. And what we're hearing more and more about now in the press and in the media is this other critical issue about biodiversity. So we end up in a situation perhaps where we need to think about how do we square the circle? How do we try to increase this amount of wood going into construction, building more wooden buildings so that we can get the benefits from the substitution and the carbon storage, but then without moving to non-sustainable practices when it comes to harvesting. And we have to bear in mind that because of climate change, then forests are changing. We are seeing more forest fires, so there are a lot of dynamics within the forest that we need to kind of understand in a holistic way. So I think it's very important that we look at these in a kind of a systemic manner. So then the question is, how do we maximize the substitution storage benefits of wood products without compromising then the sequestration and sink potential of forests, as well as these other ecosystem services, which actually then brings me on to the main topic that I would like to cover today, which is about materials efficiency and resource cascading. And I think this is kind of something that we really need to focus on in the future. I've kind of taken quite a simplistic approach to this materials efficiency. How can we be more efficient in our materials use? Well, of course, when we're manufacturing products, and in addition to reducing the energy inputs in the manufacture of our wood-based materials, we need to kind of utilize the resources effectively as possible. And I think this is kind of embodied in the concept of the biorefineries, where we use all the fractions of the biomass. We must recall that when we produce sawn timber, we only produce about 50% of sawn timber from a log, and the log is only a proportion of the biomass that's actually removed from the forest. So we need to kind of accept that we need to utilize these other fractions of the biomass as effectively as possible. And for this, we need very integrated industries that are able to use these in a very, very effective way. Another way we can look at it, of course, is, and this is maybe the most obvious one in the construction sector, is how do we extend the use time of a building? So how do we utilize buildings very effectively, as Matti was talking about, but also extend the lifetime of the building, making it more adaptable, more flexible, so we can actually extend the use time. And there's very many very good examples of extremely old wooden buildings. Technically speaking, there's nothing to prevent buildings made from wood lasting many centuries if they're well looked after and maintained. But ultimately, buildings will come to the end of their life, and we renovate during that process. So there is wood that's discarded in that process. But what we do with that is something that we have choice over. We could utilize that material in different ways to the way we're doing it now. So we could cascade. In other words, we could use for multiple purposes before we eventually dispose of the material. And I think this concept of resource cascading is quite nicely embodied in this diagram here, which kind of shows us what we typically do currently is we have a single use for a material. Let's say it's a beam functioning in a building. When the building comes to the end of its life, or the building is renovated and the beam is removed, then it's typically chipped up and incinerated with energy recovery. An alternative scenario would be that beam would be then reused in another building or in another form. It may be not quite such a demanding application, but it will still be reused before it would then be converted into particles for some other kind of product. You had mentioned about the biochar production. It could be particle board production, before eventually recovering the energy content. So this is the idea that we extend the use time of the material for a much longer period through different applications over a greater period of time. If we think about how much wood is actually going into buildings, it's a relatively considerable amount. Global production of sawnwood and wood-based panels is something like around 900 million cubic meters per year. Of course, not all of that goes directly into buildings, but a significant portion will find its way into buildings. So there's a very significant quantity, and a lot of work is now going on to look at not only how much wood could go into buildings in the future, but also how much wood is actually in buildings currently. And we've been involved in several studies to look at this. In Austria, for example, our colleagues in a project estimated that there was around 32 million cubic meters of wood in residential buildings in Austria, and this would increase over time to around 50 million cubic meters. We've just completed a study where we've estimated that just in the structural parts of residential buildings, there's around 17 million tons of wood actually embedded there. So there's an awful lot of material potentially available. We don't know so much about the types of products and the mix of products there. We don't know so much about the quality of the material, but we know roughly how much is there. We know how much material is being utilized. So going back to this idea of cascading, what we'd kind of really like to have is something that looks a little bit like this. I mean, conceptually at least. That we would have our solid wood products, which we'd maybe reuse, possibly even more than once, before we would then convert that into particles or some smaller units that might be used in particle board, for example. It would depend very much on the local industry structure, what options would be available. Particle board is not a very big product here in Finland, but it is in many parts of Europe where there's a high population density and a need for this kind of product. But it might be something else like biochar. And then maybe some fiber-based products, chemical products as precursors, perhaps for textiles, before finally the waste is then incinerated for energy. Today what we do is this. Basically it goes directly from the building to incineration, and there are many reasons for this. But of course, I mean, in essence, it makes sense to do this because we could be more resource efficient, and the studies that we've been involved in and our colleagues have been involved in have kind of illustrated that there are advantages, not just in terms of materials efficiency, but also in terms of impacts, carbon impacts, to be gained by introducing cascading. But if we go to a waste processing plant, whether it's here in Finland or in any other country in Europe, the mix of products, wood products, might be slightly different, but this is typically what we see. We see a mishmash of different broken pieces of wood with all sorts of contaminants incorporated there, which makes the reuse extremely difficult, of course. And the kinds of things that we tend to see are things like nails and screws and other metallic fixings, which are incredibly difficult to remove in practice. So this is a big limitation. We also have other materials like foams, some polyurethane foam here and some styrofoam here. There are other materials, there may be coatings, which we don't know whether they will be toxic or not. There may be preservatives in there. So there's a lot of technical challenges to reusing the material. So typically this is what happens. This is a photograph from one of our colleagues in Spain in a current project, and this is what we would see also here in Finland. In a waste processing plant, the material is chipped into smaller pieces, and then that is used for energy generation. It is possible to do something. This is from a study we did some years ago now, where we actually went into a demolition project in Porvoo and actually extracted some larger pieces of timber. We were actually interested in understanding what the quality of this material was. But it was clear that we can actually do it, and we can actually extract material from the building that could potentially be reused after some remodeling. So the key issue seems to be that, well, okay, we build our buildings in a way that makes them difficult to dismantle in the first place. And this is something that we're looking at through one of our ongoing projects, the In Future Wood project. We're looking at how might we be able to kind of build this in the future, so we can recover wood more easily, we can recover more quickly, so we avoid maybe the imperative to demolish as quickly as possible. If we can recover wood with higher quality, then it opens up more cascading options, perhaps direct reuse, perhaps into reuse into other products that have higher utility. And if we were to do this, then this would allow us far more potential to cascade, and this would then have an impact both in resource efficiency, would lessen the pressure then on our forests, which may be very important in the future. So design for disassembly. So this is why I'm now very interested in working with people like Pekka and other architects and designers and structural engineers to understand how we might be able to do this actually in practice. Sometimes I feel as though we're reinventing the wheel. This is a picture I took last summer in the Åland Islands, a log structure that's been dismantled and put under covers. We have very good solutions for this. Okay, not everybody either wants to live in a log house or it's maybe not the most practical building solution, but the concept of being able to have something that we can actually dismantle and then reuse at a later stage, I think is quite neat. I kind of often imagine why it might be that there'll be so much incentive to wish to recover and reuse logs from old buildings. And I live in an old log house, and many of the logs here are clearly from previous incarnations. I imagine that if you have to go to the forest and to cut down a tree and to form these logs by hand, you have quite a lot of investment in that material. We're very lucky to be able to walk down to or go down to the nearest hardware store and buy whatever we want at a very low price. So how we value materials, I think, is something we need to shift our thinking about. So maybe it's just some final thoughts too. I think I'm running out of time now. We know Matti and Juudit very clearly explained this, that I mean, future building is going to have a very big impact looking at the trends over the next 50 years or so, and we're going to use up a big proportion of our remaining carbon budget if we continue in business as usual. So we need to do something. Wood, we know, can have a positive impact in terms of sustainability, but we need to understand the limits to the resources and the fact that we need to think about the forest in other ways, not just as a source for material. And the resources are limited, so we need to be much more resource efficient. We can be more resource efficient by extending building lifetimes, and I think this is an important aspect, how we might do this and use buildings more efficiently, as Matti also pointed out. And we can certainly be more resource efficient and increase this positive impact if we think about reusing and recycling. And this in itself can be promoted through design for disassembly. So we need to be thinking about not just building buildings, but also building buildings that we can disassemble and we can use those materials again in the future. So thank you very much. I think my time is probably up by now. So yeah, any questions, I'll be very happy to try to answer them.
Thank you, Mark. You said yourself the question, it was something like, so what is the problem? And I was thinking that in Finland, the forests have been very important through our lives. I mean, starting from when the first people came to Finland. And now it seems that they are important in very different viewpoint, the carbon sink. And this is maybe a question for all the presenters or maybe audience as well, that is there really at the moment any better choice than wood if we think about the carbon effectivity and environmental impact issues? Simple yes or no would do good in this case. How about you, Mark?
I mean, one thing I think we should be acutely aware of is timescale. I mean,
Yes.
there might ultimately be better solutions, but we need to do something and we need to do it now. There's no point thinking about this in 10 years or 20 years time. It's going to be too late. So we can build with wood now. We have a range of very good products, and we have, I think, enough evidence to suggest that building with wood is a good thing. So we should just do it now. So I would say yes, it is the best option. We can do things probably better in the future with kind of recycling and the design for disassembly, but these are still going to take some time to implement. So we need to hit the ground running and start to just build more now.
It seems that there's a question straight to you, Mark. You partly answered the question that do we have a system for reusing or recycling wood from construction site in Finland instead of sending it to energy production? Mark, yeah. You may know the situation well at the moment.
Yeah, I had a similar question in a seminar before Christmas from a Canadian gentleman. It was I had to say that we don't really have much else at the moment. That is one of the issues that we have. It's a kind of it feels as though it's a kind of a chicken and egg situation. That we because we don't really have any options apart from maybe some niche uses of reused wood. We don't really have kind of industrial scale options for doing this. I mean, it is done in other parts of Europe and elsewhere in terms of particle board. So a lot of recovered wood is used for particle board production. But we don't have a big industry here, and I think that's one of the issues. So we do need other solutions, for example, like biochar and other things that are suited to the economy and the market here in Finland. That's not really my area. I'm more of a kind of an engineering type person, but I think this is something that we do need to develop a new kind of stakeholder ecosystems around the recovery of wood.
Yeah, you know, and I know that wood at the moment does very poorly on reuse, like it was Jennifer mentioned in the question that it mainly goes to the energy. So there's a lot of potential to improve that situation, and as one of the solutions you said that, which is very typical to wood construction, that we should design for disassembly in the beginning, since we nowadays you kind of fix the components with screws or bolts or mechanical connectors. We can open them easily if we design the buildings decently. Judit, you opened your camera. Hopefully you have a yes or no answer to my question, or even longer can do.
Yeah, I was actually starting to think about the use of forests in general, because we use them at the moment to produce all sort of short-lived products. So I'm wondering whether we could like change in general the way we use our forest, in the way that we would have like more resources for the wooden construction, and at the same time reduce less these kind of shorter lived products.
Yeah, at least in wood construction we could do that to kind of extend the service life of the wooden buildings at least longer than the cycle of the forest, meaning more than 8 years. Now the average age of the buildings in general in Finland is something like 43, 40, depending. Then there's a question by Paula. Could you?
Yeah, thank you. I was just wondering, because all of the presentations have kind of touched upon the question of extending the duration of our buildings, and I was just kind of wondering, like, what has brought us to this current situation where it seems that the life cycle is really short, that we are seeing in a massive scale buildings from the 1970s being torn down. And I try to kind of understand what has brought us to this situation, that in terms of kind of legislation and the economy of construction, and what is all the background for this current development.
So who would that?
Well, maybe I could try first. I would like to suggest that perhaps there hasn't been a dramatic change after all. If we look at the documentation of Finnish buildings from the 19th century, from vernacular studies, we have lots of documentation of buildings that are in very poor condition and that are very short-lived, and that like rotted and decomposed on their sites, mostly because of poverty, but also for other reasons. And those old buildings that survived are the best ones and that have been well maintained. And I would like to ask or question the assumption that are the modern buildings significantly short-lived than the previous ones, or is it just so that we have a biased perspective because we only see the best examples of old buildings? And while I'm questioning this, I necessarily do not argue that we shouldn't we should have short-lived buildings. Of course, we should have buildings with very long service lives, while understanding that during this long service life of the building, there are lots of components in a building that are replaced several times. Building service systems, for instance, many surface components, facades, windows, doors. So a building hosts several cycles of building component service lives. And I think it's about finding the optimum in how we, in a resource-efficient manner, handle these service lives that are occurring during a building service life.
There's another comment by Mikko Jalas. I will hand it to you, Matti, as well, that if we don't have to ask, kind of question whether we should use timber, Mikko says that we have very clear need to reduce the use of concrete and steel. Matti, from the viewpoint of Minister of Environment, where you steer all the materials kind of democratically, what would you say about that?
Well, first of all, I think that we need to drastically reduce the material intensity of our economy, regardless of what material we are talking about. So that's I think one of the most important goals. And thereafter, fulfilling the needs that are there after we have considered sufficiency, then we can improve efficiency in the use of materials and try to mitigate their environmental and social and economic harms. And of course, concrete, cement especially, and steel, as well as some other materials, are very problematic at the moment for the environment. But then again, if we look at the innovation that's there in the pipeline, we have very promising processes going on for carbon neutral steel by SSAB at the moment. They are producing that, both they are preparing the production of that in Finland and in Sweden in a large project. So that's promising, and they have promised to roll out that within the next 15 years or so. And there is also development of geopolymer-based concrete, which has from 50 to 80% lower carbon footprint than the current ones. So we will need these materials in the future, and all materials should be made in an improved manner in the future. I don't think that it's realistic to say that, yeah, we'll just switch to building all from wood. I don't think that we live in such a society in which we could just make a decision like that. There are countries, very large countries, who could do such a decision because they are not democracies, but we are, and therefore I don't feel that that's a very realistic option. I don't suggest that Mikaela was thinking of that, but while I agree with the required shift from the share of different materials used for different purposes, I don't think that we should name one material as a climate problem per se.
Yeah, I agree. But on the other hand, there is democracies, for example, France, Austria, or some countries that stated that on a public building you should first explore the wood solution. But anyway, any comment on that, Mikko?
Very briefly, thanks Matti for answering. My concern mainly or also related to what you said about densification. So just a recent example from Espoo, I heard that when they were planning the new sports arena, the major part of the carbon footprint comes from stabilizing the ground, and that's with concrete and steel. And if you think about city where, you know, the densification forces us to build on poor ground, that's like super inefficient resource use. And this is what I mean, that concrete and steel, they are the materials for the dense city and high rise, or have been, like, well, Pekka knows better that it might change, but still I think that concrete and steel use is connected to particular design or architecture paradigm, and that should be questioned as well as with the kind of or in parallel with the material considerations.
No, it's a pity that we didn't have any slides on very trendy, fancy 18-store wooden 2 million euro apartment, because that is already happening, unfortunately, in a very small scale. On the other hand, looking at Helsinki and Finland, most of the schools are built nowadays on timber, so there will be a change anyway. Then I will give the last comment to Caroline Knappers. You sent it already on chat, but could you shortly tell it to the audience as well?
Yes, so I basically just summarized that the design for disassembly should be really integrated into all the components of a building. So not only the actual building, but basically anything that's related to the building or that goes in and stays there for a long time. Light switches, you name it. So, and like, yeah, well, going then back to the wood, or starting there, that if all the paint, if all the treatments, all the glues are really already taking this into account, if they aren't harmful, that could open up the opportunity for reuse of the wood post deconstruction. And yeah, then I added there that the industries contributing to the construction sector, or those in the construction sector, need to go through a mindset and basically policy shift and start thinking ahead beyond delivery and service contracts alone. So
thank you. This discussion goes in little bit different topics on the textiles in, was it 16th? It's in on the next slide. To me, thank you everybody and the presenters. To me, this session worked perfectly and much more confused than I was in the morning when I woke up. But anyway, thank you for kind of giving few tools like designing for disassembly, reusing, recycling, extending the service life of the wood building components. Smart gardening, Juudit, it's good that small drops can make the sea as well. I guess Matti has studied that as well, that the kind of using the green infra would be good. A radical intervention on building sector, building more resilient, simple, robust, and then most of all making the peace with the nature. So how about starting from that, which is maybe the biggest issue. So thank you for joining, and as the slide says, the sustainability issues turns to textiles, which by the way could be used in architecture as well, but this may be something else. So thank you everybody, and 16th April the lecture series go on.
And on my behalf also, very big thanks to all our presenters, Pekka for chairing, and our great audience for your comments and contributions in this session.
Thank you, and have a good day with peace with the nature.
Thank you.
Ciao.